This will be geometry lesson 8.4, and today we'll be discussing finding the area of triangles. Now, if you remember, the formulas that we talked about last class would be the area of a rectangle, which is simply length times width, and the area of a square, which is side squared. Well, today we're going to continue with that, and we're going to apply and learn another new formula. Well, if we look at a triangle, and we can imagine this triangle right here, and we kind of double up and we go parallel to this side, parallel to this side, what we form is a little rectangle. Well, the triangle that we originally had is actually half of that rectangle. We talked about that in chapter 6 when we looked at a rectangle being cut in half by its diagonal, two equal right triangles. That's what happens here. So if we look at the formula as being a rectangle's length times width, or we could think of it as base times height, the formula for the area of a triangle is simply 1/2 base times height. Well, now what we need to look at is be able to differentiate between what's the base and what's the height. Okay. So if we look at this triangle, this is the base and this is the height. Now the thing about this is if we rotate that guy and we flip it over, this being this side, well, now we could look at this being the base and this being the height. So they're actually one and the same, so it doesn't matter which way we go. Right? Now, the height, what we define the height as in geometry, it is the perpendicular distance from the vertex to the opposite side. Okay, so in this case, if we go, here's the vertex, the perpendicular distance to the opposite side is right there. Now, the reason we say perpendicular distance is because if you'd measure the distance from the floor to the ceiling, and you'd measure straight down, but then you'd measure at an angle, what's going to happen is that distance is going to get longer and longer the more angle you have. But straight down perpendicular is the shortest distance. That's why we say the perpendicular distance. So in this case, this was the height. But now if we look at this being the highest point, the vertex, if we go straight down perpendicular to the base, now the height is actually on the inside. So we have the base here, the height here, and this is just one leg and this is another leg, or two sides. Okay, so we don't know what those are. Right? So if we look at this one though, now this is an obtuse triangle right here. This can still be the base. That would be the distance from here to here. But the height we would actually have to measure on the outside. You could imagine if we took this side and we extended this side. We talked about sides extended forever and ever. Maybe that this is the table that triangle's sitting on. Well, the height of this guy would be the distance from the table up to that vertex. And now this is actually measured on the exterior of the triangle. So that's not even part of the triangle or not even within the triangle. Right? So let's go ahead and apply this formula. So we want to find the area and the perimeter of the following shapes. Remember, perimeter being the distance around, area being the area covered. Alright, so if we want to calculate the area, what we first need to look at is what's the base and what's the height. Okay, so we have two perpendicular sides here, so this would be the base, this would be the height. Now perimeter we could go ahead and do right away. Perimeter we would just take 9 plus 12 plus 15. That's 21, 26, 36. So my perimeter would be 36. Now remember, we calculate perimeter as a unit of length, so that's just 36 meters. Right? So now when we go to area, when we calculate the area, here's my formula, 1/2 base times height. So the base of that guy we could call 12, and the height of that guy we could call, I'm going to go 12 meters. The height of that guy we would call 9 meters, all right? So now when I do this, guys, it's just 1/2 times 12 times 9, but I look at half as 12. Half of 12 is 6. 6 times 9 is 54. And then look at what we have again. We have meters times meters, and if you remember, meters times meters is meters squared. So my area is 54 meters squared. Okay. Now the first one, the height, I just wanted to practice and have you kind of do that. After today, we aren't going to do that anymore. But the height of this guy could be 9, or it could also be 12 meters. It depends on which way you're looking at that triangle. So what we're going to do on number 2, all right, so let's go. We have this base as being 8. This hypotenuse, remember, that's the hypotenuse across from the right angle, is 10. We don't know the height, so what we first have to do is do a quick calculation, and we should be all over this. That's Pythagorean theorem. So we're going to go h squared plus 8 squared equals 10 squared. That's h squared plus 64 equals 100. Subtract 64, subtract 64. H squared equals 36, and h is 6 when we square root that. That's Pythagorean theorem for about the couple hundred time right there. Alright, so we know that the height over here is 6. So that's our height is 6 feet. Now remember, we could also consider 8 as being the height, but then we would have had to calculate the base. Alright, so let's go perimeter real quick. Perimeter would just be 6 plus 8, 14 plus 10, 24. Now remember, that's a unit of length, so it's 24 feet. And the area of this, so when we calculate area, area is going to be 1/2 times the base times the height, which is 1/2 times the base of 8 times the height of 6. So again, the way I look at this, is it's half of 8 is 4, 4 times 6 is 24. So we have 24 units squared, 24 square feet. Alright. Alright. So we can go to the next problem now. Look at number 3. Alright, so first off, what we want to look at is what's the height of this guy. The height is 16 centimeters. Now the perimeter, we can't find the perimeter. We need to find this hypotenuse first before we can calculate perimeter. So what we would do is we would go a squared plus b squared equals c squared. And then we can go find the height there. So it would be the square root. Let's see what we get when we take the 16 squared plus 30 squared. That's 1156. And then we square root 1156, and we get 34. Okay, so the hypotenuse of this guy is 34. So now what we can do is we can take that and we can calculate the perimeter. So we add up all around. 16 plus 34 is 40, 50. 50 plus 30 is 80, and my label is centimeters. All right. So now when we go to calculate area, area of a triangle, remember, is 1/2 base times height. That's half of a rectangle. Half of a rectangle. So we go 1/2. The base we're going to use is 30, and the height we're going to use is 16. Okay, so you can throw that directly in your calculator. What I like to do is I don't like half of 30. I like 30 because it's got a 10 in it. I'm going to take half of 16 is 8. 8 times 3 is 24. With the 0 is 240. So that's 240 centimeters squared. So that's your area. Again, all you had to do is take half 30, 1/2 times 30 times 16, and you were done. Let's go to number 4. Okay, number 4, we're going to have to do a little bit of work here. If we look at the height of this guy, the height is the perpendicular distance from the vertex to the base. Well, there's the height, so the height is 12 meters. Now, perimeter we'll get to here in a second. First off, let's go to area. Okay, so if we look at area as 1/2 base times height, and I'd like you to write that every time. The more you write it, the better remember it. 1/2, the base is 10. The height is 12. I like 10. I want to keep that 10. So what I'm going to do is I'm going to go half of 12 is 6. 6 times 10 is 60. So my area is 60 meters squared. Okay. Now let's go back and calculate perimeter. Perimeter, we got to do some work on here. Now if you look inside here, you do see two right triangles. Now what we need to do is what's the distance, because this is isosceles, what's the distance from here to here? Well, this would be 5, and this guy over here would be 5. All right, so you can see this little right triangle right here. So we have 5, 12, and we need to find the hypotenuse. So we can do the math on that. 5 squared plus 12 squared equals c squared. That's 169 equals c squared. Square root, c is 13. So this other side over here is 13. Now remember, this is isosceles. So if this is 13, what's this side over here? 13. So what we have is we have 13 plus 13, 26. 26 plus 10 is 36. So my perimeter is 36 meters. Good. Same process here. Let's go to here now. If we look at this, we don't have the height in here. So we'll get back to that. Let's go to perimeter first on this guy. So if we know that this is 5, this is 5. Now we take 5 plus 5 is 10. 10 plus 6 is 16. So the perimeter is 16 yards. Now what that is, that's the distance around. So that would be the distance around there, and that's just the length. Now what we need to do is we need to calculate the height of this guy. So to calculate the height, again, we have an isosceles triangle because we have two equal sides. What we need is the distance from here to here. Well, if this whole side is 6, take a wild guess at what this side is. 3. Alright, now what we have is a handy-dandy little right triangle inside there. So we can use our Pythagorean theorem again. It states that this is the hypotenuse. We have 8 squared plus 3 squared equals 5 squared. This is another one I told you I'm going to use over and over again. 3 squared is 3 times 3, which is 9. 5 squared is 5 times 5, which is 25. You subtract 9 from both sides. These are in our algebra. That's 16, and we would square root 16. So what number times itself is 16? 4. So the height here is 4 yards. Now what we can do is we can go calculate the area. So the area calculation, we need area formula for triangles, 1/2 base times height is half of a rectangle. You have 1/2. The base of that is 6. The height of that is what we just calculated is 4. So we take half of 6 times 4, which is 12 yards squared. Okay, so our area is 12 yards squared. All right, so that's our area calculation there. All right. Let's go ahead and go to 6 now. 6 is kind of the same process. We have a triangle. Now again, I keep trying to make this a little bit more difficult every problem. So if we look at number 6, do we have the height right away? You betcha. We actually have a couple heights if this is the right triangle. Here's a height. Again, we could rotate this around. This could also be a height. Or we could rotate around a little more, and that could also be the height. Right? So this problem is actually not to scale. So let's just use this as the height, and this is the base. All right. So when we go to calculate area, no, the height, let's use this 4. We have 1/2 base times height. The base is, let's call 13. The height is 4. So remember, we can use the commutative property of multiplication here. We can just go this way. Let's go half of 4 is 2. 2 times 13 is 26. So we have an area of 26. Label it inches squared. Now perimeter we can just go ahead and find. So perimeter we can just go ahead and find. We would just take 12 plus 5, 17. 17 plus 13. 17 plus 13 would be 30 inches. So there's both our measures that we need. All right. Now again, let's look at a compound figure. Let's look at a compound figure. The reason we keep doing these is when we get to chapter 9, we're going to be looking at surface area, and that's what surface area is. A bunch of areas added together. So what we have here is we have a triangle and a rectangle. Well, let's calculate the area of a rectangle. That's real easy. That's length times width. That's 9 times 15, so that's 90, and 45, that's 135. So that's 135 meters squared. All right. Now let's go up here to the triangle. What we have to look at is what's the base of this triangle. So if we look at the base of this triangle, we actually have to do a little bit of work here. Look down to where that's 15. Okay. So the area formula for that triangle, I'm going to come down here and do my work, is 1/2 times the base of 15 times the height of 8. So again, what I like to do is kind of rearrange it. I would take half of 8 is 4. 4 times 15 is 60. So we have 60 meters squared in this triangle. Now remember, we did these with rectangles and squares. To find the total area, we just have to add those two guys together. So we take 60 plus 135, which is 195 meters squared. So that's our area. Now to do perimeter, we have to do a little bit more work. Now remember, this 15 is here, but is that part of the perimeter? No, it is not. But we're going to need it. The reason being is I know 8, I know 9, I know 15, I know this is 9, I don't know this. So we need to do a little bit of math to find this side over here. It's Pythagorean theorem again, just with that right triangle there. There's your side opposite, that's your hypotenuse. So when we do the math on this, it's going to be 8 squared plus 15 squared equals x squared. And then when we go ahead and do that, simplify that, you get 8 squared plus 15 squared equals, oops, you get 289, and then you square root 289, you get 17. Okay, so the x is 17. So now what we could do is put 17 right here, and we can go through and calculate our perimeter. So add them up. I'm going to start right up here. I'll go 17 plus 9, 26. 26 plus 15 is 31, 41. 50, 58. So my perimeter is 58 as long as I added those up correctly. Alright, so that's how we do a compound figure. Same process, just find the areas and then add them up. But perimeter, just add up all the sides on the outside. Another one right here. What we have here is we have two shapes again. We have a triangle on top of a rectangle. So when we calculate perimeter, we'll get to there here in a little bit. Let's do area first. So if we calculate the area of this rectangle, it's 44 times 10. Length times width. So 44 times 10 is 440. So we have 440 square feet here. Now for this triangle, we have to do a little bit of thinking. We need to find here to here is 2. The distance from here to here is 44 if you look down. So what we need then is to find the, this is 2, so we need to find the total length of this as 44 plus 2 plus 2. So that total length is 48 right there. So the total length of this triangle, the base of this triangle, is 48. So we go to calculate area of this guy, it's going to be 1/2 times the base, which is 48, times the height, which is 7. So we take 40, half of 48 is 24, 24 times 7, and we get 168. So the area of that triangle is 168 square feet. So we have 168 plus the 440 that we had there, and we get a total of 608 square feet. So our area is 608 square feet. Now for perimeter, we're going to have to do a little bit of work here for perimeter, because if you look at what's missing is, okay, we know that this part inside here is 44, but we don't care about that. We know that that height of that triangle is 7, but we don't really care about that for perimeter as well. So what we need is we need to find these legs. We need to find these legs of that triangle. Now to do that, we have to look at each end of this right triangle that's right here. Now remember, we said that whole side was 48. So if this whole side is 48, what's the distance from here to here? Well, half of that. So that would be 24. Okay. So now what I want to do is I'm going to take a little snapshot of this bad boy so you can see it. Here's my little right triangle that I'm going to bring down over here. Well, that's my isosceles, and we can look at that as just the right. So this whole side was 48, but half of it was half of that, which is 24. Right. So now when we go to calculate this third side, it's 7 squared plus 24 squared, which equals c squared. So we throw that in our calculator. We go 7 squared plus 24 squared, and you get 625. And then you got to square root that. So square root of 625 is 25. So c is 25. All right, so what we have here is we have that this side is 25, and this side is 25, so we put that back in our original drawing, and now we can go calculate perimeter. Now again, it's just adding around the horn, so I'm going to mark where I started. I'm going to go 25 and 25 to start. That's 50, 52, 62, 106, 116, 118. So the perimeter of this is 118, and that's just feet. Alright, so now we go to the next problem. Here's some work backwards ones, just like we did last class. In the following problems, the area is given. Find the missing length. So the area of a triangle is 24 square feet. So what I would do is I would stop, and I'm going to write the area formula for a triangle. 1/2 base times height. The area is 24. That goes here. Alright, so step 1 was write down the formula, and then step 2 we had to substitute in, so we put 24 there. We have 1/2. The base is 8. And what we're trying to do is calculate the height of this guy. So we have to do a little bit of algebra here, just like we did last class. So we have 24 equals, I'm going to simplify this guy right here. Half of 8 is 4 times h. Now we have to solve that guy. So how do we get rid of times 4 here so we have just our height? Well, we divide by 4. Divide by 4. So h is 24 divided by 4, which is 6. Okay, now step 4, 1 formula, 2 substitute in, 3 simplify and solve, 4 label. This is the height. The height is a measure of length, so that's going to be 4 or 6 feet is your answer. Right? So let's go to 10. Same process here. The area of a triangle is 30 centimeters squared. So what I would do is I would stop, and I would write the formula down. So area of a triangle is 1/2 base times height. Okay. 2. Let's substitute in. The area is 30. We know that. 1/2. The base, we don't actually know the base. It says, what is the base? I'm going to underline what I'm trying to find. What is the base? The height we know is 5. Okay. So now what we're going to do is we're going to simplify this. Now I'm going to go ahead and do this. You can do this. It's no problem. We look at half of 5. So what we're going to do to simplify this is we're actually going to take half of 5. Well, half of 5 is 2.5 times b. Right? So now we're to the same process. We got to solve this. So we got to get rid of this times 2.5. So we're just going to divide by 2.5. Divide both sides by 2.5. That's Gandhi. So what we have then for B, we take 30 divided by 2.5, and you get 12. Now remember, the last part, step 4, is you have to finish this with a label. So this is the work I want, and that's your answer right there. Those are your answers. So again, I'm going to ask you to write the formula every time on these problems because that's what we want to do. So we get nice and organized. Let's do one more of those. Number 1, the area of a triangle is 18 millimeters squared. So the first thing I'm going to do, area of a triangle is 1/2 base times height. 2, let's substitute in what we know. The area is 18 millimeters squared. The height is 4 millimeters. So we know that the area is 18. We know the height. We don't know the base, so we're going to leave that. And the height is 4. Right. 3, let's simplify anything we can. So we have 18 equals. Now again, what I'm going to do is I'm just going to rearrange this. This would be 1/2 times 4 times b. Well, half of 4 is 2b. And we got to solve it. So instead of multiplying by 2 to get rid of that, we would divide by 2 because those are inverse operations. That's gone. So 4b equals 18 divided by 2, which is 9. Right? Now again, step 4 says label, so my label is millimeters, not millimeters squared, just millimeters because this is a measure of length of the base. Right? So your homework will be to finish 8.4, lesson 8.4. If you have any questions, please come see me during seminar or before or after school. And good luck, and we will see you next class.